All right, so you guys were to work through these guys right here. Finish these up. Let's take a look. If the OH is this, what is the pH? So we're going to go ahead first and take, this is the hydrogen ion concentration. So to find the pOH, we take negative log of that. And that's the pOH. If we want to find the pH, we have to take 14 minus that. And the pH would be 13.61. pH at 13.61, is that an acid or a base? That is a base. The pH is over 7, right? Here we have the pOH given the hydroxide ion concentration. So that is going to be quite easy. We just take the negative log of each of these, just like you did for your assignment. So that's 0.985. And here's the hardest question of the day. 0.96 pOH. Is that an acid or a base? That is a base. If the pOH is less than 7, then it is a base. If the pH is less than 7, it is an acid. That's just something that you've got to sit there and take 3 minutes and sit there and wrap your head around, right? Memorize that out. Determine the pOH. If the pH is this, so the pH is 8.9, acid or base? pH is 8.9. The pH is 8.9, acid or base? pH is greater than 7, it is a base. The pOH is 5.1, less than 7, it is a base. So make sure that you get that down in your head. You got to know that. So where it says D here, this is the pH is 8.9, that is an acid. I'm sorry, a base. Then they had some problems that were mixed. I'll do one of each. Determine the hydrogen ion concentration if you know the pH is 1. To find the hydrogen ion concentration from the pH, remember you take the antilog of the negative, and we get 0.1. If it were the pOH and you were trying to find the hydrogen ion concentration, then you would take 14 minus the pOH. That gives us the pOH. So then we take the antilog of the negative pH, and that is 1 times 10 to the negative 12. Determine the hydroxide ion concentration. Well, it's the same as up here, except for it's a little different. It's the hydroxide ion concentration. So we take the antilog, 1 times 10 to the negative 1. Or if we've got to put it in the calculator, the antilog of negative 2.98. We get 0.001. That right there is enough to make me want to go to my scientific notation mode. So I'm going to put that entry in again. And we get 1.05 times 10 to the negative 3. There we go. And then the homework was to go through these. The only difference this has is these weak acids and bases, where you actually see they have the Ka given to you. So basically, to find the concentration of hydrogen ions, you take 3.0 times 10 to the negative 8, which is the Ka. You multiply it by the molarity of the acid, and then you take the square root of it. That's a little different of a formula. Anytime they give you the Ka or the Kb and they want you to find those concentrations, you're going to use that formula. All right. Brings us to our next to last topic overall for the year. Kind of exciting. Next to last topic overall for the year. That is the Bronsted-Lowry acid-base theory. Bronsted-Lowry acids and bases are included in the Arrhenius acid base. So if it starts with an H or ends in an OH, it fits it fits the definition we know. If it starts with an H, it's an acid. If it ends in an OH, it's a base. The problem with this is certain things did not end in OH. Bronsted and Lowry saw this, so they came up with the definitions as such. Acid is a hydrogen ion donor. A base is a hydrogen ion acceptor. A conjugate is something that complements or forms after. Like the conjugation of a verb. Where does it go? At the end, right? At the end, right? So it's after. Conjugate acid is formed when a base gains a hydrogen ion. A conjugate base is formed when an acid has donated a hydrogen ion. So in the following equation, it says label the Bronsted-Lowry acid and base, and the conjugate acid and conjugate base. So if we take a look here, we have HS and NH2. HS became what? S2 negative. So did it donate or receive an H? Donated. So that makes this the acid. And that means that a conjugate base is formed when an acid has donated. That makes this the conjugate base. NH2 negative goes to NH3. NH2 negative goes to NH3. So what do we have here? That would be a conjugate or a base, and this would be the conjugate what of the base? Yeah, that would be the conjugate acid. So acids become bases and bases become acids. Remember, the only difference between an acid and a base then becomes a hydrogen. If it donates an H, it becomes a base. If it gains an H, it becomes an acid. So this question here says, which of the following are conjugate acid-base pairs? So we're going to say yes or no on these. The only difference between them can be an H. If you lose an H, you gain a negative. If you gain an H, you lose a negative. So is the only difference between H3PO4 and PO4 negative 3 is the only difference in H? No, the difference is 3 H's, right? So that's not going to work. How about here? HSO4 negative 1 and SO4 negative 2. It's the only difference between those in H. Matter-wise, HSO4 and SO4. Well, let's take a look. SO4, HSO4. So yes, that matches. Now the second thing we got to check is a charge. If we take away an H, we should gain a negative. So this one does not have the H, and it went from -1 to -2. So this works. That's a good one. How about HBr to BRO, -1? This is just like where they give you two pictures and you look at the pictures and you find what's wrong. Is the only difference here in H? HBr and BRO. Let's take a look. I'm going to cover up the H. Are these two things identical? Ignore the charge for right now. No, we have this extra O. Where'd that come from? Won't work. How about this? HBr and BR -1. BR. This one has an H. So that checks out. Now we got to check the charge. When we lose the H, do we get a negative charge? Here is with the H, so the charge is 0. Here is without the H, and we have a -1. So that one's good. HCN, CN -1. HCN, right? We cover it up. CN, CN, we're good. We lose an H, we gain a negative. So that one's good. You should do 7, 4, and 8 on your own tonight. Let's take a look at what other kind of problems we've got. Each of the following chemical equations identify the conjugate acid-base pairs. So this is just like that first exercise we did. We're looking for something here that loses an H and gains a negative charge. Does HF lose an H or does H2O lose an H? HF loses an H. So it's an H donor or a hydrogen ion donor. It's an acid. Automatically, what does that make H2O in my mind? Because if there's an acid, there has to be a base. So the acid becomes the conjugate base, and the base becomes the conjugate acid. In reality, if we look at this in the reverse direction, F negative accepts an H. H3O plus donates an H. So you should do that exercise. 15 to 22, write the conjugate acid. The conjugate acid, these substances are a base. So they're going to gain an H and gain a +1 charge. If we gain an H, HSO4 becomes H2SO4, and we get a +1 charge. +1 will take a -1 and cancel it out. SO3, well, we gain an H, so it becomes HSO3, and we get a +1 charge as well. So -2 becomes -1. Pretty easy. These guys down here, these guys are acids, and we are writing the conjugate base. What do acids do? They are hydrogen ion donors, so they lose an H. So H2S becomes HS. When you lose an H, you lose a positive, so you become negative. HS -1, well, again, we are losing an H, so we become S without an H, and then we gain another negative, so it becomes -2. Go ahead and complete up to number 30. That's all I got for today. Make sure you get the lab in for tomorrow. So if you're not done with that, please get it in, get it done. I will create breakout rooms if anybody wants to work with the people that were in here before.